AntSim is part of our BioSim project. We work with young children, ages 1st and 2nd grade, and they use electronic ant puppets or push toys to sort of pretend to be an army ant. And it sort of helps them take a first-person perspective on what the complex system of an army ant is like, and so they get to think about the challenges of being an army ant.
So children are learning about systems thinking, and they're also learning about the biology content, about the lives of insects, and about ecologies in their everyday lives.
They also have electronics embedded, so there are sensors that help the computer note the location of a particular ant in the space. They also are tracking the army ant's energy levels. The eyes in the ant change colors as the energy levels change. They can track how much food the ant is holding, so they can basically hold 3 pieces of food, so they can see lights that indicate whether they have 1, 2, or 3.
One of the reasons we chose ants after bees is because of the ways in which it's both similar and different. It's similar because the ants are still communicating to each other about how to find food, but it's different because instead of using a dance, they're leaving a chemical trail which stays on the ground over a period of time.
Ants lay a trail pheromone that tells other ants where to go to find food or shelter. A trail pheromone persists beyond the time that the ant has been there producing it.
On the ant puppet, there's a compass that is lit up with blue lights, and that sort of helps you know that you are on a pheromone trail. With every few steps they take, they drop a pheromone scent along the way, and so other army ants can smell and sense that as they go. And the better a food source is, the stronger that pheromone trail is, because more and more ants are leaving those trails.
How do you think they make the bivouac? What do you think they're doing to make the bivouac?
In the classroom, the instructor will talk to the children, try to get an idea for whether they know what's going on, and also sort of gather their strategies for how they can be as quick and efficient as possible.
I will go to every single one, and then I would go back to the bivouac, and then I would remember which one had the most in it, and then I would spread a pheromone trail from there to that one.
So from the food source?
From the bivouac there.
Okay.
How else could rain make it hard?
If it's raining really hard, it might wash the pheromone trail away, and it might wash the food away.
As the kids run around the classroom with the army ants, we're constantly collecting data on what the ants and what the children are doing in the classroom. So the location of the ants is being tracked so we can tell sort of where they go, whether they take straight paths or whether they take more winding paths to get to where they're going. We can track how much food they're gathering. We know which colony is getting more food than the other and how quickly that food is coming in. So we have a lot of computer data that's helping us sort of figure out what the kids are actually doing. We can also show some of that back to the children and have them reflect on their own actions and think about how they could continually keep being more efficient.
Okay, their group found a very close food source, and that everybody in the group went straight to this food source, got 3 bites, left a pheromone trail back.
It also sort of gets them to think in new ways, and these are really complex ideas that are usually saved for later grades.
So guys, looking at this, do you think that laying the trail every time and following the food source was a good idea and worked?
Yes.
Yeah.